Good day, this is Professor Will, CBMD PhD, and today is Monday, June 21st, 2021. It is 7:56 and 49 seconds p.m. Eastern Standard Time, and today's research, supermassive black holes. And don't forget to check out my website. Well, let's hop to it here. Discovery of a dying supermassive black hole via a 3,000-year-long light echo. Date June 8, 2021. Source Tohoku University. The supermassive black holes, SMBH, occupy the center of galaxies, with masses ranging from 1 million to 10 billion solar masses. SMBH are in a bright phase called active galactic nuclei, AGN. AGNs will eventually burn out, since there is a maximum mass limit for SMBH. Scientists have long since pondered when that will be. Researchers may have discovered an AGN toward the end of its lifespan by accident after catching an AGN signal from the ARP-187 galaxy, and through observing their radio images in the galaxy using two astronomy observatories, the Atacama Large Millimeter Submillimeter Array, ALMA, and Very Large Array, VLA. They found a jet lobe, a hallmark sign of AGN. However, they noticed no signal from the nucleus, indicating the AGN activity might be silent already. Upon further analysis of the small wavelength data, they found all the small-scale AGN indicators to be silent, while the large-scale ones were bright. This is because the AGN has recently been quenched within the last 3,000 years. Once an AGN dies off, smaller-scale AGN features become faint, because further photon supplies also shut down. But the large-scale ionized gas region is still visible, since it takes about 3,000 years for photons to arrive at the region's edge. Observing past AGN activity is known as light echoing. Researchers use the NASA NuSTAR X-ray satellite, the best tool to observe current AGN activity. It enables non-detection, so we were able to discover that the nucleus is completely dead. The findings indicate AGN turn-off occurs within a 3,000-year timescale, and the nucleus becomes over 1,000 times fainter during the last 3,000 years. Researchers will continue to investigate dying AGNs moving forward. They will search for more dying AGN using a similar method as this study. Researchers will also obtain the high spatial resolution follow-up observations to investigate the gas inflows and outflows, which might clarify how the shutdown of AGN activity has occurred. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.